Hey,
Oh,
hello.
We're back.
We are back.
sure.
And I'll close that window. There we go. Hey, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Edutainment, the Sunday Night Astronomy Show. Hey,
Yay!
um,
I feel like we're the two old guys on that the Muppets, Mike and I.
Waldorf and
yeah,
yeah.
Waldorf and whatever his name is.
Mark says, finally have time to watch live. Hey, welcome, Mark. Good to see you here. Hey, my name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm also an amateur astronomer, just an amateur, and a member of the Royal, a 20-year amateur astronomer there.
There you go.
And also a member of the Royal Astronomical Society of Canada. And I'd like
Hey,
to welcome back. Hey, welcome back to my regular two co-hosts this evening, Mr. Mike Powell from PFO Observatory here in St. John. Welcome back, Mike. Hey.
Yay!
And my other co-host, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton. Paul, good evening.
oh,
Lisa says, good evening from the great Garden State. Good evening, Lisa and Janice and Robert. Whole bunch here. From cloudy London, Ontario. Sorry about that, Chris.
Glad to hear.
It's cloudy here too. So, yeah.
that's right.
Okay. I'd like to welcome back all of you on YouTube and Facebook land as well out there, and to all of those who have been welcoming us through the local Rogers TV network. Thank you for your support, Rogers. And on tonight's episode of the Sunday Night Astronomy Show, now there are objects in our solar system besides planets and the moons that deserve our attention. Asteroids, the large chunks of rock orbiting the sun along with us, harbor secrets of the beginnings of the solar system. Now, only a few robotic spacecraft have ever encountered asteroids up close. So tonight we're going to have a little discussion around asteroids, what we know of them, how we study them, and if there are any that we know of that could pose a danger to mankind. Also, a few of the missions that have been out there, the past and current missions. Also tonight, Mike will bring back another vinyl bud for timely binocular target. So, yes,
Yeah,
Ed, so that's why we let you go last week. Okay. Paul will have another interesting Rosanna's fun fact to
Indeed.
share with us. And I'll provide a quick look at the week ahead along with some of your wonderful photo submissions. So let's get started, then, guys, with a discussion around other celestial neighbors besides our planets and moons.
Gonna be a rock show.
Oh, for rock stars.
Oh, my picture up there in the corner, that's because it's 2 months tomorrow since we had that event.
It's our, yeah, isn't that something?
2 months.
We
Wow.
waited for a long, long time for that, and then it seemed like it was never going to come. And then all of a sudden it came and it went, and now it's like, wow, it's just flying by.
Yeah.
We're focused on it anymore, I guess. But
Yep.
however,
Here we are.
all right, let me just get this here up and going because I guess I'm going to start the yak, aren't I?
If we get an asteroid blocks the sun like that, we're in big trouble.
Yeah. Big trouble.
Big trouble.
Big John. Big bad John. Okay, I'm going to share my screen. So what I'm going to talk about to get the thing started, we're all going to talk a little bit about asteroids and what's out there in our solar system and so on. So I'm just going to do just a brief overview of a few of the things or the objects that are out in our solar system, and just kind of do a quick overview. Then Mike's going to get a little more detail with some really cool stuff, and then Chris is going to talk about some obviously cool planets and a special little maybe thing that someone can do. I'll leave that to Chris to talk about. All right, so let me share my screen, and I'll get started. Okay, so we're going to talk about the belts of our solar system. And there are three. There's actually another one Mike and I were talking about. There's actually four ones that are specifically called these based on what they're actually made of. And the first one, of course, is the main asteroid belt. And that's the one that, we'll talk about a fair bit about that one, actually. So that's the one that's between Mars and Jupiter. Then there's the Kuiper belt, which is just beyond Jupiter, or beyond Uranus, I believe. And our little ninth planet guy actually resides out there. And then there's also the Oort cloud, which is a bigger and even further out yet again. And there's another one I didn't put on here, and it's called the Jupiter Trojan. And it's basically a belt of asteroids that follows the same orbit as Jupiter, and it's kind of shoulders them on both the left and the right side. But I won't get into that one tonight. Oops. So the main asteroid belt. So the main asteroid belt is located between the orbits of Mars and Jupiter, and between 249 million and 740 million kilometers from the sun. So it's a little ways out there. Let's see if I can do it this way. Was that no? Okay, I'll do this. See, I'm going the right way here on my thing. There we go. So the main asteroid belt. So within the main asteroid belt, scattered in orbits around the sun, are bits and pieces of rock left over from the dawn of the solar system. Now, most of these objects, called planetoids or asteroids, meaning star-like, orbit between Mars and Jupiter in a grouping known as the main asteroid belt. The main asteroid belt lies more than 2.5 times as far as Earth does from the sun and contains millions of asteroids. And most of these are relatively small, from the size of boulders to a few thousand feet in diameter, but some are significantly larger than that. Oh, by the way, if you're looking at this image here, you can see where Jupiter is, which is the largest circle, and the Trojan asteroids. I just mentioned that I didn't have a slide on the first. That's where they lie on either side of Jupiter, and basically they follow Jupiter's orbit. So the main asteroid belt, early in life of the solar system, dust and rock circling the sun were pulled together by gravity into planets, but not all of the ingredients created new worlds. A region between Mars and Jupiter became the asteroid belt. Sometimes scientists call these little worlds minor planets. One, Ceres, is technically a dwarf planet, and these objects move mostly between the orbits of our solar system's fourth planet, Mars, and fifth planet, Jupiter. Astronomers once thought they were leftovers of a rocky planet that Jupiter's gravity tore apart long ago. Now they think differently, and they think that the asteroids are likely simply remnants of a formation of our solar system 4.6 billion years ago. Some astronomers have suggested that a separate planet formed between Mars and Jupiter, but the impact at a high-speed comet broke up and scattered this new body to create what we now know as the main asteroid belt. Now, most of the asteroids in the main belt are made of rock and stone, and a small portion of them contain iron and nickel metals. The remaining asteroids are made up of a mix of these, and more distant asteroids can contain more ices as they get further out. Now, we'll go into our next belt system, and this one's called the Kuiper belt. Now, the Kuiper belt lies outside planet of the outer planets. And the Kuiper belt is like a ring of asteroids and dwarf planets just beyond the 8 planets that we normally think of as our solar system, and roughly in the same plane. It is similar to the asteroid belt found between the orbits of Mars and Jupiter, and Pluto, our little friend that the 3 of us still consider a planet, Pluto's orbit extends into the Kuiper belt. And so basically those what you're looking at there are the various orbits of the planets. So of course the green one being Saturn, violet being Uranus, Neptune is the orange one, and Pluto is the yellow one. So Pluto really is the only one that actually lives within the belt. So the Kuiper belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units to approximately 50 astronomical units from the sun. Now, an astronomical unit, for those who don't know, is the distance from Earth to the sun, is 1 astronomical unit. It is similar to the asteroid belt, but far larger, 20 times as wide, and 2 to 200 times as massive. Like the asteroid belt, it contains many small bodies of remnants from when the solar system first formed. While many asteroids are composed primarily of rock and metal, most Kuiper Belt objects are comprised of larger volatiles, ices, such as methane, ammonia, and water. The Kuiper Belt is home for most of the objects that astronomers generally accept as dwarf planets. For example, Pluto, Orcus, Haumea, Quaoar, and Makemake. Some of the solar system's moons, such as Neptune's Triton and Saturn's Phoebe, may have originated in that region. Now, astronomers believe there are millions of small icy objects in this region, including hundreds of thousands that are larger than 60 miles or 100 kilometers wide. And some of the objects, including Pluto, are over 600 miles wide, 1,000 kilometers. That is huge. The other one, the other formation, if you will, that was in that image, of the first three that I showed you in the beginning of this chat, is called the Oort cloud. Now, the Oort cloud lies far beyond Pluto and most distant edges of the Kuiper Belt. While the planets of our solar system orbit in a flat plane, the Oort cloud is believed to be a giant spherical shell surrounding the sun. Planets and Kuiper Belt objects. It's like a big, thick bubble around our solar system made of icy, comet-like objects. The Oort cloud's icy bodies can be as large as mountains and sometimes even larger. Now, I don't know if I did. I'll get this information in. Okay. So because the orbits of long period comets, which take more than 200 years to orbit the sun, are so extremely long, scientists suspect that the Oort cloud is the source of most of those comets. For example, comet C 2013A1 Siding Spring, which made a very close pass by Mars in 2014, will not return to the inner solar system for about another 740,000 years. The distance from the sun to the Oort cloud is so enormous that it's useful to describe it not in the more common units of miles or kilometers, but in astronomical units. One astronomical unit is the distance between Earth and the sun. Pluto's elliptical orbit carries it as close as 30 astronomical units from the sun and as far as 50 astronomical units. The inner edge of the Oort cloud, however, is thought to be between 2,000 and 5,000 astronomical units from the sun. So the outer edge might be 10,000 or even 100,000 astronomical units from the sun. So that's 1/4 of halfway between the sun and the nearest neighboring star. And that's pretty much what I have on a basic rundown of the belts of the system. So I'm just going to stop sharing.
I say that Oort cloud is freaking huge.
Unbelievable. You know, like, we thought the solar system was big.
Yeah. Man, I didn't realize how, it wasn't until I started doing a little research how big I figured that Oort cloud really is. Like, it's massive.
It's unbelievable. Yeah.
Well, alrighty, I'll continue on where Paul left off. Now there may be one or two little things here that we overlap each other on, but that's okay. We're all looking at the same information one way or the other anyway. See if I can share my screen here. Did that come up?
Yep.
Alrighty. So again, where do asteroids come from? Well, there's the Oort cloud, and scientists now actually believe that about 2% of the Oort cloud is actually asteroids. The rest of it is mostly these icy comet-like shapes or whatever Paul was talking about. And then there's the Kuiper Belt. Now, scientists don't know how many asteroids are in the Kuiper Belt, part because they have no idea how many Kuiper Belt objects there really are. There's just so many out there. And then, of course, the asteroid belt between Mars and Jupiter is estimated to contain between 1.1 and 1.9 million asteroids that are larger than a kilometer. That's a lot of big rocks out there when you think about it. So just a few amazing facts about asteroids. Like Paul said, they're relics from the time that the solar system was born. There are millions and millions of asteroids in our solar system. We are lucky enough that a lot of them aren't hitting us. Some asteroids actually became moons of the planets. Asteroids can have moons, rings, and tails of their own, believe it or not. And of course, there are all kinds of different shapes and masses. It's just unbelievable, the different shapes. There's some that look like dog bones, some that look like long sticks. They're very rich in minerals, and someday, if we have the technology, we would like to go out and mine them, because there's a lot of money out there if we could mine an asteroid that's solid gold. And believe it or not, asteroids, some actually have liquid water gullies in them. Now, that's hard to believe that there's liquid water on an asteroid. I could see ice, but apparently there's liquid water found on some of them. So here's an interesting one. If they were to come our way, how much damage could an asteroid cause? Well, the damage an asteroid causes is directly related to its size, composition, and speed. As you might imagine, the bigger and faster the asteroid, the greater the threat. So a small asteroid, less than 80 feet or 25 meters, will usually burn up upon entering the atmosphere and usually results in meteors, or at worst, small meteorites that actually hit the ground. Medium-sized asteroids, 80 feet to 360 feet. An asteroid in this category could cause significant local damage. That was the one that went over Russia there, the Chelyabinsk, is that how you pronounce it anyway? And it falls into that category. Large asteroids, 360 feet to basically half a mile or 1 kilometer. This could cause regional destruction if it hit us, with such collision causing devastation consequences from fires to tsunamis to potential climate change. Fortunately, these events are rare, estimated to occur about every 10,000 years or so. And I'm glad we're not in that 10,000 year time frame at this point. Then, of course, there's the massive asteroids that are greater than a kilometer. These are the most terrifying. A collision with an asteroid of this size would be globally catastrophic, potentially causing mass extinctions. For existence, the asteroid impact that is believed to have helped cause the demise of the dinosaurs was roughly 6 miles or 10 kilometers in diameter. Thankfully, these strikes are exceedingly rare, with a significant impact estimated to occur about once every million years or so. So we're pretty lucky that these big ones have kind of stopped coming in and hitting us, and I suppose we'd have to thank Jupiter for that. I just wanted to show this quick slide. I found it, and I thought it was quite impressive, the different sizes that we found just in the asteroid belt alone. So if you look down here, it's the number of asteroids. On the side is the diameter in kilometers. So if you were to pick 1,000-kilometer wide asteroid and move across, the diameter greater than 900 kilometers, there's only, and come down the line, there's only one, and we call that Sirius or Ceres. There's some pronounce it something like that. But if you move down out there, diameter greater than 200 kilometers, you come across, there's over 1,000 that are over 200 kilometers in size. And then you get, you look at this one here, it says diameter of 50 kilometers in size, and come down to it, again, the first one diameter was 100, then 1,000. We work our way down to simple ones, like a diameter greater than 30 kilometers. That's still a pretty big rock. That 30 kilometers, there's 10,000 of them out there floating around. And then you get down to something that might be 1 kilometer in size. I mean, that's a pretty big rock still. 1 kilometer in size. You come up here, come down. There's 1 million of those floating around out there. So when you start looking, you're going, geez, there's some big rocks that are hovering around out in our solar system. And you just don't think about how many there are that are huge and could destroy the Earth if they hit us. So then, what if they did? Well, there are just 3 asteroids at this point that NASA thinks could possibly crash into the Earth in the future. You see here the Empire State Building at 1,454 feet. You got this one that's 29075 or 1950 DA. That's 4,265 feet, and it's due to hit us possibly in the year 2880. Well, I won't be around for that one. And if I was, I'd take a case of beer to the beach, sit down, and watch her come, because nothing else I could do. Then we have Bennu. That's 1,000 or 1,600 feet across. It's due to hit us maybe in the year 2182. And again, I won't be around for that. And then the famous Apophis that everyone talks about was supposed to hit us in 2029. Well, they recalculated and found out it's going to miss us in 2029, but it could possibly hit us in 2068. And that's 1,200 feet across. So that would still do some mighty big damage if it ever did hit. So then we look and we say, well, okay, we got asteroids and meteors and comets out there. What's the difference between them all? Well, an asteroid is a large object size mainly composed of rock and metals, with some ice between 1 meter and 100 kilometers in size. What's a comet? Well, a comet is mostly a chunk of ice with dust and rock. And, when it gets closer to the sun and it'll sort of burn off or vaporize, it'll create a tail. What's a meteoroid? A meteoroid's a piece of rock or metal in space that floats around between 2 millimeters and 1 millimeter wide, and it's still floating out there. And it doesn't become a meteorite until it comes into our atmosphere. And then we have what's called a meteorite. And we've all seen fireballs. So a meteor brighter than Venus caused by a slightly larger than exponentially fast moving meteoroid. So it's just a bright burnout of one coming in. A bolide to me was always the same thing. And then a meteor is a streak of light that we actually see. We call them shooting stars. So there's the difference between all of that stuff. And we're just talking about asteroids tonight. But if you did want to try to capture your own meteorite, I come across this. I found it was pretty cool. You can actually go and get your own micrometeorites out there. What do? Get a clean bucket, wash it all out, make sure there's nothing inside, and place it on the ground where it won't be disturbed. And there's a clear, open sky above it. So no trees, no overhang from a roof or anything like that. You want clear sky above it. Leave the bucket there for several hours, 4 to 8, maybe even longer. The longer you leave the bucket, the better your chances are of actually collecting a micrometeorite. When it's time, bring the bucket, place a lid on it, and take it inside. So you want the lid so no other debris gets in there. Place a magnet in a baggie bag. Take the top off the bucket, reach the baggie bag in with a magnet and swirl it around inside the bucket. Check the magnet and see if there's anything stuck to it. Use a magnifying glass or microscope to examine the particles stuck to the magnet. And guess what? If you find round, dark particles with pitted surfaces, you may have found yourself a micrometeorite that came from space, because 800 tons of space dust lands on the Earth every day. And this one's my bad. An asteroid impact some 65 million years ago contributed to the extinction of the dinosaurs. Whee! So now we know what happened. The mammals had paws they could hold on. The dinosaurs had pads. They got flung off. So if you want to learn, what's that?
And then the Earth became round.
Yeah. And if you want to learn more about asteroids, actually, one of the greatest places I went to was, of course, sciencenasa.gov/solar system/asteroids. And it tells you everything you want to know about anything that we do know about asteroids. And the current known asteroid belt, or asteroids in the asteroid belt that we know of so far, and now have actually counted as 1,351,400. That's a lot of rocks out there. And here we go. I had to throw in a painful pun of my own. What did the asteroid say to the Earth? Dude, can I crash at your place? That's the end of that.
Yeah, a lot of information there, guys, both of you.
Yeah, that's
Lot-
interesting
lot
to
to
see, what we didn't see, and I was hoping we'd see it, what damage it can do to what size relation to what damage it does.
There's actually a website you can go on. I forget what it's called right now, but I'll look it up and I'll post it after. That you can go in and you put the size of asteroid you want, pick your spot on the map, and it'll tell you the damage it does when it hits around you. So if you pick like MEPAC, for instance, if MEPAC, the one that was we were lucky enough to have named after us, if that hit St. John, it would wipe out New Brunswick completely. So
wow.
I just had to look it up that day.
That would be a MEPAC political statement, wouldn't it?
It would definitely would.
Absolutely, 100%. Okay, thanks, guys. My little contribution to this is basically, Trudy says, I just watched the movie Armageddon today.
That'll do it.
That'll do it, yeah. Oh, I got to say hello to my brother Danny, who's out there, watches us every single week. So, hey, Danny.
Hey, Dan.
And my sister's watching here tonight, too. So, hey, sis. Okay. Let me speak off here, do something else. I'm going to try to go. And well, first of all, I'm going to share my screen. And this one, I guess. You up there? Yep.
Yeah.
Okay, so my chat is just about asteroids. I gotta get my other screen here, just 1 second. It's gonna be this one. Asteroid missions. So just a couple of the current missions that are going on right now to learn a little bit about asteroids and a little bit about past and maybe perhaps a couple of future missions coming up. So it's pretty quick. There's not that many slides. Anyway, let's talk a little bit about this one, the mission to Psyche. Mike talked about all those minerals out there and all that gold. And this is the one here that might be the contributor, the largest contributor anyway. Now, the Psyche mission is a journey to a unique metal-rich asteroid orbiting the sun between Mars and Jupiter. Now, every asteroid we've explored so far has been made of rock or ice. But metal-rich asteroids are also powerful windows into the solar system's past. Now, what makes the asteroid Psyche unique is that it appears to be the exposed nickel-iron core of an early planet. It's likely the survivor of multiple collisions, which would have stripped away the mantle, exposing just the metal-rich core. So if we want to see what it's like at the core of our planet, we can't drill down that far, and the pressures and temperatures are too high. This may be an example of what our early Earth may have looked like at the core. Now, it was launched on October 13th of 2023. The Psyche spacecraft, with its solar panels, is about the size of a tennis court. The body of the spacecraft is slightly larger than a small van, and the spacecraft includes a gamma ray and neutron spectrometer, a multispectral imager, a magnetometer, and an X-band radio telecommunication system. Now, it's powered by solar electric propulsion system. That's a different system. Apparently, it's been tested once in the past, and it doesn't really use a whole lot of rocket fuel. It's or hydrogen or whatever. It's not used primarily on this mission, so it has great gas mileage. I'll call it that. The Psyche mission is also testing a sophisticated new laser communication technology called deep space optical communication that encodes the data in photons to communicate between a probe in deep space and Earth. So this may be something that we'll be using for these long duration space flights in the future when we're out looking at farther out worlds, for sure. So this is a test run for that as well. So Mission to Psyche had launched on October 13th. It hasn't arrived yet. I think it's about halfway there. So we're going to pay attention to see what happens here. Now, they said there was more minerals on this. I think it was more, was it gold? That if you tried to mine this and bring it back, well, of course, the value of that metal would just drop like a stone because you had so much of it, right? So anyway, it's going to be an interesting mission to find out what it's like if we could look at our iron core. For our core. Another mission that we're looking at right now, or that is taking place right now, is called the Lucy mission. Now, the Lucy mission, Paul touched a bit on this, the Trojan asteroids. The Lucy mission is designed to make a flyby observations of 8 asteroids, 1 main belt asteroid, and 7 asteroids that are orbiting ahead of or behind Jupiter, known as Trojan asteroids. Now, the Trojan asteroids are asteroids trapped in the orbit of Jupiter, excuse me, in two swarms. Its primary science objectives are to study the surface composition, the surface geology, the interior, and the bulk properties of the asteroids, and conduct a search for satellites and rings about the objects. Lucy launched on October the 16th of 2021, and in May 2023, Lucy performed a series of small DSMs, flight maneuvers, and flew within about 430 kilometers of its first target, diameter 790 meters asteroid. That's not really small. 152830 Dinkinich on November the 1st of 2023. The Trojans are clusters of rocks, grains, and exotic ices that don't coalesce into planets when the solar system formed, or didn't. They're among the best preserved evidence we have left from that period, and are thus key to explaining how the solar system came to look the way it does. Lucy's primary mission of 12 years is NASA's longest yet. And within 12 years of its October 2021 launch, Lucy will fly past 7 different Trojans, giving scientists a taste for the variety these objects come in. There are more than 10,000 such rocks, and no mission has ever studied them up close. The thing about this mission is that it's 12, they've already planned it to be 12 years long. So they're looking at people that work at NASA that work on this mission and are saying, you know something, are you about to retire? Because if you are, we need to bring in an apprentice underneath you to train before you leave NASA or JPL. And they've actually considered that in part of their equations or costs, I guess, associated with the mission. Over 12 years, it's supposed to cost something like $931 million. And part of that cost is actually replacing retirees that will come up, just like the Voyager mission. I mean, the Voyager mission now is what, 46 years old? People have spent their whole career on this one mission. And some of them are in their 90s now that it started this mission. So it's the fact that these missions are getting so long. We've got the Mars missions that are still going on. We had Cassini run 20 years. They're getting a long lifetime. They're getting their warranty and more out of these missions. So they had to consider these factors when they're looking at missions like 12 years long. Okay, so that's a couple of the missions that are taking place right now. Now, other notable missions that have happened in the past was the Double Asteroid Redirection Test mission, or DART, in 2021. That was the one that went out and had the kinetic impact test to asteroids Didymos and Dimorphos. So that was the one where we tried to see what kind of force we could apply to an asteroid to push it out of its way, push it out of our way, if necessary, down the road. OSIRIS-REx mission from 2016, that was a sample return mission to asteroid Bennu that brought the sample back to Earth. Hayabusa 2 JAXA in 2014, that was another sample return mission to an asteroid. A few more notable ones were the Dawn spacecraft. That was a NASA orbiter of asteroids Ceres and Vesta, the two largest asteroids. Hayabusa in 2003 was a Japan sample return mission to asteroid 25143 Itokawa. And Deep Space One in 1998 was a NASA flyby mission to asteroid Braille. So those are some of the past missions, the successful missions. Moving on to a couple of future missions. Now, there is a couple that are being considered right now. NEA Scout actually did launch back in 2022. NEA Scout was a CubeSat, so that's a smaller satellite, or it's a small satellite. It's like a box, maybe the size of a bread box, a little bit bigger. Roughly the size of a large shoebox. There it is. It was to be propelled by a solar sail and take pictures of a near-Earth asteroid. Now, after the launch, though, the project team was not able to communicate with the spacecraft, so there's some issues there. They're still calling it an ongoing mission, and I think they're still trying to talk to it. And then the Hera mission, coming up in 2024, which is the follow-up mission to asteroid Didymos and Dimorphos. That's the one that the DART spacecraft had impacted with and caused a bit of a change in its trajectory. So they're going to examine the first test of the asteroid deflection, performing the first survey of a binary asteroid system. So we're going to go out now and see how much of an effect that little bump caused with the path of these two asteroids. So a couple of interesting missions there. And finally, I guess, do we have a mission to BPAC?
There we go.
There we go. So yeah, I think we're all in favor of a mission to BPAC, the three of us anyway. Why not? Current magnitude, it shows at 17.9 on Stellarium. Mike was saying it's up around 13.2 now, but it is showing in Sagittarius now, just under the teapot of Sagittarius. It rises at 156 and sets at 831, so it's not up very long. It's fairly low to the horizon. It's currently about 2.4 astronomical units from the sun, and its distance from us is about 1.63 astronomical units. So we are on the same side of the sun as MEPAC right now. We have just talked before we come on the show here about is it possible for any one of us to image this object? And at 13.2, that's a pretty dim object. Would you notice it in a telescope? Probably not. You might not know exactly like what kind of reflectance that object actually has anyway. Some, obviously. But the better idea might be to take a long exposure of it, or and maybe take a snapshot of that part of the sky one night, and then take a snapshot of the same part of the sky the next night, and then maybe even 3 nights in a row, and watch to see if you can find an object that's moving in one of those one of those photographs. And that one that moves might be me back. So I recommend a mission to NASA. We're going to put that request in tonight, I think right after the show, and we'll see what they say.
Yeah, NASA, that.
Yeah.
Sounds like a plan. Wonder if we could charge them rent.
Yeah.
Yeah, that's right. That's
Yeah.
right. Maybe we get somebody to land on it.
Who knows, right?
Who knows?
All right. So we're gonna go from there. Angela says hi, Chris and Danny. Hey, Angela. Okay, let's go from there to a vinyl bud. I'd say next one. Are we done talking about asteroids? I guess.
I think we've kind of covered that pretty good. It's an interesting topic, I think. Lots going on out there, and there's some things that are a little larger than we thought, and the impact that some of these things can have. And Mike and I think we're talking a little bit. I don't know if you were on that conversation or not, Chris, about what we see as shooting stars that come through. Are any of those from the asteroid belt, or is it just the dust that's in and around us and the space stuff that's falling down? I mean, it can be a lot of different things, I guess.
Yeah, if two rocks collide out there, it's bound to send smaller rocks and dust our way eventually.
Yeah.
Millions of years, sure. Yeah.
Yeah.
Yeah. It's
I can't imagine being around, when the main impact stuff was going on, when some of the big ones were hitting the Earth way back when. Like that must have been crazy. Some of the big stuff that was hitting us. In fact, that's not it may not have been an asteroid, but I mean, if something collided with the Earth and it created the moon, there must have been pieces of that still floating around out there too that would have been considered an asteroid at the time, I guess.
Yeah.
It's crazy.
Yeah.
I know it's one of my favorite arcade games myself, so asteroids.
Wasted a lot of quarters.
Space Invaders was another good one. Space Invaders lost a lot of quarters at the Bull Hall. Bull Hall on King Street, King Square, lost a lot of quarters there.
Yeah.
All my part-time job, every dollar out of my part-time job was spent there, over and over and over again. Anyway, a lot of fun though.
All right.
Okay, let's get from there to a vinyl bud.
All right, moving on, as they say. So that should be coming up. Binocular target of the week this week by Vinyl Bud is, and we've come across this one once before. Eddie's roller coaster. Yeehaw!
Hey.
So, invented by a British astronomer, Eddie Carpenter, known as Eddie's coaster, the meandering double-dipping wave of faint stars lies about 3 degrees northeast of Gamma Cassiopeia, at the center of the W in Cassiopeia. Eddie's coaster includes more than a dozen stars spanning 2.7 degrees. A chance alignment reminded Carpenter of an amusement park ride, which led to the asterism's name. So how would I find it in the sky? Well, if it was a clear night, and lately we have had a lot of clear nights, but tonight is not going to be. But if you went outside at 11:30 or 23:30, you oriented yourself 30 degrees northeast, looked up, you find the W of Cassiopeia, and find that center star, the W, and come straight up from it, and there's your coaster right in there.
Yes, sir.
So it's a double dipping slider. A little closer look again. Here's the W from a different perspective, but you look up and there you can see it, and it does. It looks like the old roller coaster from what's that place in New York?
Coney Island.
Yeah, Coney Island roller coaster.
Yeah.
And here's a picture of it, and there's a picture of Eddie Carpenter, the founder of it. But you can see, look at that. It makes a perfect little double dip.
Yes, sir.
Love it.
Now, in 10 by 50 binoculars, if you find Nuvia over here and come straight off, look at that. It's a biggie. At 2.7 minutes or whatever seconds, it's pretty big size. You'll know when you're on it with a pair of binoculars. Compared to the full moon, whew, that's a 5 across. So that's a pretty good size. Are you ready for this one?
Mm-hmm.
What did the time traveler do when he was still hungry? He went back for seconds. 4 seconds.
Oh, wow.
Yeah.
Oh.
And that's binocular target of the week by Vinyl Bud. 4 seconds.
That's one of the better ones, Mike. Must say.
It took a while to sink in, I think.
Yeah, well, that's it. I got to think about this for a minute.
All right. How about a Rosanna's fun fact next?
All right, we can try that. All right, let's see if I can pull this one off again. All right, so that's this week.
Rosanna's Fun Fact.
Hello, Rosanna. Welcome back to it. And she has got an absolutely wonderful fun fact. And of course, it is timely with the times that we are keeping. So let's dive right into it. Once I find it. Whoop, I just hit the wrong thing. I do that every time, you know. Maybe it's this one. There we go. Okay, so let's start with this. So Rosanna writes, hi, Paul. It's that time of year again that there are colorful rainbows everywhere celebrating Pride Month. And it is also that time of the year when children might be singing Glory, Glory, Hallelujah. Teacher hit me with a ruler. I knock her on the beam with a rotten tangerine, and there's no school no more. Or at least that's what it was when I was singing in elementary school back in Massachusetts. So she had an interest. I'm going to have to talk to her about that sometime. So it's the perfect month to talk about glories and rainbows in space. So if you look up the word glory, which is a noun, a verb, and an interjection, you won't find the astronomy-related meaning until you get to the number 5. And number 5 says, of course, is a ring or spout of light, such as aureole, or B, a halo appearing around the shadow of an object. Now, that isn't perhaps the most exciting definition, so here's a better one. Let me just roll that up. There we go. A glory is an optical phenomenon resembling an iconic saint's halo around the shadow of the observer's head, or above, rather, the observer's head, caused by sunlight or, more rarely, moonlight interacting with the tiny water droplets that comprise mist or clouds. So recently, astronomers have spotted evidence of the meteorological phenomenon known as a glory on another planet. If this were Mars or Jupiter, it would be remarkable enough. But the planet in question is WASP 76b, which is millions of times further away than either of them outside the solar system. This is an artist's impression of a suspected glory on an eastern edge of WASP 76b's day side. And this image credit is from ESA work. So that's kind of interesting. To define a glory even further, it consists of one or more circular rings that display the colors of a rainbow, red on the outside and violet on the inside. Although also caused by bending of light by water droplets, glories differ from true rainbows because backscattered light is diffracted between water droplets rather than refracted when entering and leaving them. Glories get their name because they look like halos around the heads of saints in medieval paintings, which may in turn have been inspired by glories. I've heard a similar story about a chicken and an egg. So far, a glory has been an Earth-related experience. There's a reason no glory has been seen outside of our solar system, as it requires very peculiar conditions, explains Olivier Demangin, there we go, an astronomer at the Institute of Astrophysics and Space Sciences in Portugal, and also lead author on the study that may have found the first ever outer space glory. So first, you need atmospheric particles that are close to perfectly spherical, completely uniform, and stable enough to be observed over a long time. The planet's nearby star needs to shine directly at it, and with the observer just at the right orientation. So I think that's what that's all about, the layout. In 2014, the European Space Agency, or ESA, did spot a glory in the clouds of Venus. So Venus glory doesn't look colorful in images like these, but the circular patterns can be seen, and the patterns at different wavelengths reveal its resemblance to glories on Earth. Now what you're seeing there are 3 different wavelengths, ultraviolet, visible, and near infrared, but because they're actually monochromatic and no color's been assigned, you don't see them much. But Here is a simulated view of glory on Venus, and on the left and the Earth. The difference in ring size reflects, no pun intended, the much smaller size of the droplets on Venus. So on Earth, it's water droplets that make glories. Almost 20 types of atoms, ions, and molecules have been identified in WASP 76b's atmosphere already. One of these, or something not yet found, might produce the glory effect. So these findings are not proof of water. However, anything causing a glory would need to be perfectly spherical and highly reflective, even the famous iron rain on WASP 76b. And this is an artist, Martin Kornmesser's impression of iron raining from the skies on WASP 76b's dark side, where it is cool enough for vaporized iron to actually liquefy. And this could be responsible, although the authors of this latest study consider a more complex scenario much more likely. So we wait for more space rainbow glories to be discovered. We can hope to be lucky enough to see a few of our own right here on Earth. After all, it is the start of thunderstorm season in New Brunswick. Oops, did I get the next picture? No, I didn't get the top of that one, but that's okay. So glory be.
Rosanna's Fun Fact.
Hey.
That was this week's Rosanna's Fun Fact. And glory be to Rosanna.
It was glorious.
I don't know where she comes up with them, but she has an amazing repertoire of them. And then she does have a YouTube channel too. I got to bring that up next week on where she puts all these after she brings them up on our site, because she does have them all listed there as well.
Yeah, that's right.
Yeah,
So thank you,
Awesome.
Rosanna. An
Thank you,
absolute
Rosanna.
fun fact as usual.
as usual. Thank you. Interesting stuff. Wow. Okay, let's go to a few photos. I just have a few photos to share tonight. Get my the right spot here. Up with this over here. Da, 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 da. I know. Okay, share my screen.
Want us to talk amongst ourselves again?
Screen two. No, that's okay. I think we're almost there. Okay. All right. Here we are.
Oh.
All right. Well, we'll get this one from Brad Perry. Brad says, "Hey, Chris, just sharing this image I got on Thursday night of the Milky Way over a field full of fireflies.
Awesome.
I got my
Wow.
composition sorted out and star tracker polar aligned toward the end of the blue hour. Now the fireflies were then captured with the tracker off using the same technique one would use to get star trails. Then once astronomical twilight ended, I powered on my tracker and captured the sky. Pretty cool shot.
Very, very cool. Very nice.
Fireflies, look at them.
Yes,
All kinds.
sir.
Nicely done. Thanks, Brad. Good imagination there, sir.
Yeah, absolutely.
Right, I'm gonna go from there to Matthew Dupre's shot. He said, "Hey, Chris, here's a capture I got of the Sauder region."
That's the
Where's
butterfly.
that at, Paul? Where's that at, Paul?
That's
Any
right. Second star in from Denevin, our favorite constellation season.
I know it had to come up sooner or later.
We know where that one is.
We're heading to that season, aren't we? Huh? Yeah.
We are.
My favorite's Hercules. Yeah. Anyway, okay, or maybe Sagittarius. Anyway, hey Chris, I'm gonna show these pictures anyway because they send them in, so why not?
That's a
I
really
got
nice
this,
photo. It did a good job on that, Matthew.
Yeah.
Awesome.
Awesome. He said I got this last week. It's 97 minutes of total exposure time, and taken with my Celestron 9 1/4 Hyperstar, ASI 2600. Nicely done, Matthew.
Very
well
nice.
done. Yeah.
Very nice.
Thanks for that. Here's another interesting one. This is from Chris Benoit. So Chris
Yeah.
says, International Space Station transiting into the sun,
You got it.
Cool.
across
Yeah.
the sun, but not into the sun.
You got her.
The video mode was Nikon D3200 on the Celestron refractor telescope, 1/4000th of a second at 25 frames per second. So there it is. So there is a site you can go to. What's the name of that site, Mike?
Yeah. ISStransit.com or something like that.
Something like that, yeah. So it does give the times and locations where you would be on the planet to be able to catch this. Now, of course, it's going to go by the sun in about a quarter of a second, so you don't have much time to you wouldn't have any time to see it. You just see a blip maybe across the screen, but video will allow you to capture a frame of it, and it actually shows the times when it will pass, and it shows the actual path of it across the sun or the moon. Yeah, either one. So he captured it. I assume that's where he went to get this information, but
Yeah,
nicely done.
just Google ISS Transit Finder and that'll take you right to the website.
Awesome. Thank you. And thank you, Chris.
Very nice.
I'm going to get this one from Robert Gadet, Messier Object 81, Bode's Galaxy. He said 45 minutes exposure on a C-Star S50. Processed in serial, finished in Photoshop. He said it was 2:30 a.m. and he had to go to bed. So
There you go.
Oh,
Yes, sir.
that's
nicely done.
Bodes.
Bodes, yeah.
Very nice.
Bodie.
Moody, yeah. Okay, from there we're going to go to our June, July calendar. That's out now. Kurt's put this out again. Kurt Nason from our local club and Raska veteran, who puts the calendar together. And this one is actually June, July. So we've got. Have we got? No. I was thinking about Mount Carlton. That's not till August, is it?
No.
Yeah, August.
I think the Kujabakrak guys had a nice day on Friday, I saw, but I think it clouded in for them over the rest of the weekend. So it's too bad. That's one of the 4 this year. Last year, they were really bad.
By the way, on June the 30th, it's actually Asteroid Day.
Oh, it is. Oh, cool.
Yeah.
Okay, it's also SNAS night too.
Yeah, get your quarters out.
Yes, that's right. Yeah.
So we have 1, 2, 3, 4, 5 SNAS heroes this month. Yay!
Yay! Bonus.
We'll go up to this week. We've got Moon near Regulus on Tuesday night, and the Lunar X can be shown on Thursday night, and first quarter moon with the lunar straight ball, which is a fault line on the moon that looks like a cliff, but it's actually just like a rolling hill. But it shows up really nicely in a telescope and binoculars. I think you can get binoculars. Anyway, that's available on Friday night. So keep an eye out for those two. Some clear skies. And this one, of course, comes from Lisa's Lookup. Lisa puts out this calendar every month. This is her June calendar. So she lists here as well the items, the event, the date for it, the peak time of the event, and the seeing tools required. Naked eye, binoculars, or telescope. And you can follow Lisa at Ruby Moonbeams on Instagram, X, or formerly Twitter, Mastodon, and Facebook, and now on Threads. So thank you, Lisa.
Yes.
And if you'd like to send photos in, we'd love to show them, as you can see. So send them in to astronomybythebay@gmail.com, and we'd be happy to put them up on our next broadcast.
Ta-da.
Oh, why don't you guys chat about asteroids here for a second or something so I can get the closing.
You know, something I'd like to talk about maybe sometime, because the summer's coming up. Well, actually, only a couple more weeks we'll be in the solstice, and I put that picture up behind me here just a few minutes ago, and I wanted to maybe just do a little chat on how I was able to get the picture to look like that. And anybody can do it. This is like so simple. It's just too stupid to be good. But it's so simple to do, and I'm going to talk about that. There's a special filter I have that I just put over the front of my camera lens, and it makes the stars really, really pop when they're large, and it really maintains the colors and stuff. So it's just something that if somebody who wants to get into taking some pictures of the Milky Way or constellations, you know, when they're out, they want to kind of start doing what Perry's been doing there. There's a lot of really easy things you can do in very inexpensive ways to be able to do this kind of photography, and it's a lot of fun, and to get you out in the summer night sky too. So
Right, exactly. Okay, hang on a second, and I just need to do this and do this and do something else. Always away. Yeah, so I'm down one monitor tonight, so I'm just kind of moving things around. It's not easy to run this part of the show.
it's not easy being green.
Gotta get an AI.
Oh, huh?
Gotta get an AI.
That's right.
Yeah, it's true. Okay, well, so that's our show for this evening. I hope you enjoyed the program tonight. And special thanks again goes out to Rosanna for fabulous fun facts. Rosanna, always an interesting topic for sure. Thank you all to who've been sharing the program for us as well. Remember too, we do love getting your photos, so send them into astronomybythebay@gmail.com, and we'll be happy to put them up on our next broadcast. Special thanks again to our friends at Rogers for joining us this evening. So until next week, wishing all of you clear skies. As we like to say, guys, open your eyes to view the skies and keep your scopes. Point it up.
Yep.
Good night, everybody. See you next week. And we'll go to our closing screen. Here we go. I think this is it.